Okay, let's take a look at a real-world example where we can actually see circles coming together and actually giving us information about our Earth. So here's an interesting fact. The summit of Mount McKinley, that's a really, really tall mountain, is approximately 20,300 feet above sea level. The question is, what is the distance from the summit to the horizon, to the nearest mile? Let's think about that. So you're standing on top of the world, almost literally. You're on top of Mount McKinley, and if you look out, you, of course, can see the very edge of the land, the furthest out point of the land that you can, and that's the horizon. And the question is, what's that distance? Well, let's draw a picture of this and see what we have. So this circle represents the Earth, which we're modeling as a circle here. And now we're standing here at E. That's the top of Mount McKinley. So really, in fact, the mountain is here. Let me show you what it is. Here's the mountain. Boop, 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 boop. And you climbed all the way here. You were climbing and climbing and climbing, and you finally made it. And now the point is, after you climbed up there, you want to know the distance from where you're standing to the horizon. Well, you look out, and the horizon, the furthest point on the horizon, is going to be that very last point that you can see before the Earth starts to curve in and around. So it's that point, that's the horizon. So we want this distance right here. Well, what do we know? Well, in fact, that is part of a tangent line because it just grazes the great circle of the Earth. And if we draw in this radius here, there's an amazing theorem that links a tangent line to the radius that's drawn to that point of tangency. It turns out no matter where you put the tangent line, as long as you draw the radius that touches that point of tangency, the angle made is a right angle. That is a really important and cool fact. I love this fact. In fact, I really do. And it's important. So all we've got to do is figure out this length. And we happen to know, scientists have told us, that the distance from the center of the Earth out to the ground, to the boundary of the Earth is approximately 4,000 miles. So if we could just find this length, then in fact we could use Pythagorean theorem, which says this squared plus that squared equals that squared, to figure out this squared. Okay, so how do we do that? Well, we actually know how tall Mount McKinley is. That's given to us. It's given to us to be 20,300 feet above sea level. And that's feet. This is miles. We have a little conversion. But that's no problem. We know how to do that. So if I take the distance ED, and we know that to be 20,300 feet, then all we have to do is divide that by how many feet there are in a mile, which is 5,280, and we get approximately 3.84 miles. So in fact, how many miles did we travel up there? Roughly 3.84 straight up. So if this is 3.84, we know this is still the same as the radius, so that's still 4,000. So the total length of this is, in fact, what? Well, you know, that's going to be 4,003.84. It's that length, 4,000, plus the little 3.84 we just found. All right, so now we've got a little Pythagorean theorem going on here, which I love. Gotta love the Pythagorean theorem. It's probably the most important and the most famous theorem that we'll ever see. So, Pythagorean theorem says 4,000 squared plus this thing, and I don't know what that is, so I'll give it a name. I'll call it question mark. You could call it X. Most people call it X. I'm going to be a little silly and call it question mark to show you the math still works. So question mark squared equals, well, the hypotenuse squared, 4,003.84 squared. Now I've got to solve for question mark. Well, so I'll subtract a 4,000 squared from both sides, and so therefore it goes away here, and I just have question mark alone. And then I can take the square root of both sides. I'm taking the positive square root since question mark actually represents a length. And so I see the square root of 4,003.84 squared minus 4,000 squared. And if we compute that on a calculator, we see approximately 175, actually 0.3, but let's round to 175, and the units there are miles. So how far is that? What is the distance to the horizon? It's 175 miles. You've got an amazing view from Mount McKinley, and geometry allows us to figure out how long that view is. Cool.